Hello, everyone. Good morning and good afternoon and namaste. Myself, Jayesh Pamnani, as a host of ICICT 2022. Dear authors and invited guests, welcome to the technical session 4C. On behalf of Global Knowledge Research Foundation, it is my great pleasure to welcome you to the 7th International Congress on Information and Communication Technology through Zoom. Further, as you are all aware, we have been facing new normal situations while overcoming the pandemic. Hence, the conference has been shifted to a hybrid mode. We are very thankful to everyone present on this platform to go along with us digitally for the conference in this unpredictable situation and making this conference more productive. Also, we wish everyone and the family a protected time. We hope you will enjoy this knowledgeable and interactive digital session. Also, there is a special note for the presenters. You will be given 10 to 12 minutes for the presentation and 3 minutes for question and answers. On 10 minutes, I will raise a gentle reminder. And I request while the presentation is going on, other participants kindly be muted. There is another request to all the participants that you all stay connected with us till the closing remarks. Just before we start, I would like to introduce you all to the chairperson for the session, Dr. Leng Jung Han. I would request.
Hello, can you hear me?
Yeah, ma'am,
Hello?
you are audible quite.
Okay. Uh,
Hi.
my name is Ding Zhuo. I'm the section chair of this section. And there will be 6 papers present in this section. So uh, let's welcome the first paper present by Muniru Ula, and the paper title is Systematic Review on Detecting Cyber Attacks Threat by Social Network Analysis and Machine Learning. Okay, let's start.
I would request the presenter please start sharing your screen and start with the presentation. Over to you.
Hello, can hear me, everyone?
Yes,
Hello.
we could
Okay.
see you. Yes, yeah, we can hear you.
Okay. Thank you.
Yeah, please share your screen.
All right. This one has disable participant screen sharing. Can you enable the screen sharing?
I would request you to please try it once again.
Okay. Can you see my presentation?
Yes, sir. It's perfectly
Yes,
visible.
yes.
Okay. 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 I would say thank you very much for uh, this organizing committee to give me the chance to present our research. Okay, this actually is preliminary study for our project. The title of our presentation today is Systematic Review on Detecting Cyber Attack Threat by Social Network Analysis and Machine Learning. We are from Indonesia, from Universitas Maliku Saleh. Introduction. This research review is to provide up-to-date overview of the research that analyze the information content in social media message for detecting the event or act that reflect malicious behavior that threaten cyberspace. This review is a preliminary research for better understanding the state of research in social media analysis and machine learning in cybersecurity field. The result of this research will contribute to create better mechanisms that help detect and prevent the risk of future cyber attack. Uh, social media and cybersecurity event. Social network has become a great mass medium for the dissemination of information, various topics such as politics, entertainment, technology, and many other subjects, including information security. The importance of analyzing the communities and information content in social network is it can extract the information and provide an in-depth look at the operation of cyber attack group using the modeling and semantic analysis. Research method. Okay, first one is a research question. Research question we use in this systematic review. First, what are the events related to cyber attack detect in social media networks? And then, what are the main cyber attack distributed on social media networks? Then, what information in social media network used for the detection of exploit that could represent the future of cyber attack. This is the step of our systematic review. First step is definition of the research question, and then we get the research review scope here. And then the second process is search process, and then we get all the papers from the search process. And the third step is searching of paper, relevant paper, and then keywording using abstract, and then the last one is data extraction and mapping process, and we get the result is systematic mapping. Okay, first one is search protocol. Search protocol is first one is we define the population. The population is the research article related to area of information security and social media analysis. The object is cyber attack and the control is social media. And the result is the analysis of social network and cyber security event and detecting cyber attack using the information published on social network. Two major databases choose as is Google Scholar and then the Institute of Electrical Engineering IEEE Explorer. The language and filter in data source. The filter determined for the search cover only study in computer science, written in English. And then the term and the synonym are presented using the OR operator to group to the term and the synonym, and the AND operator to select the term or the question structure, population, object control, and result. The keyword used as follows, like a cyber attack or cyber security or hacking or penetration or institution, or social media like Twitter, Facebook, Instagram, and we use machine learning or deep learning. Data collection process. From the search keyword generate based on term and synonym, a total of 457 articles is written. After tabulating the article, the redundancy eliminate. Altogether, we get 132 redundancy were found. The title and the abstract of the article are read to select article related to this study. In all 21 studies, we were selected. Result and analysis. First result is we get is the detection of cyber attack in social network. This review of literature revealed 4 different approaches to detecting cyber attacks. First one is detection of events related to cyber attack. And the second one is detection of type of cyber attack. And the third one is interest in software vulnerabilities to carry out cyber attack. And finally is cyber attack on social media. Type of cyber attack. The study presented at this section are aimed to detecting and classifying the different form of cyber attack on social network that can trick the user to interact with the content in the message. As the examples such as assessing site with malware, terror URL, social engineering message, spam, and malicious content. So from this type of attack, we get from our systematic review. We have five paper from Leo. Uh, from this paper we get the what is the objective, what is the algorithm that they use, and what is the accuracy, and then we find that many of them get a higher accuracy like 0.95 accuracy for SPM algorithm, and then random forest algorithm also very high accuracy, and the lowest accuracy is for logistic regression and PCA. And then interest in vulnerability for the use of exploit. So the comparison of the result between investigation focus on the interest in vulnerabilities to use in exploit. There are 4 paper we get from the database, and then we research the objective, the algorithm, and also the accuracy. And then for algorithm, they use like SPM, only 0.45 accuracy, and then for FEEU or FLUT, they only get 0.514, and for random forest it's a bit higher, they get 0.67. And there is no information about accuracy that got from NER and SWRL. And then the other thing we see is cyber attack on the same social media. This section refers to whose objective is the detection of cyber attack directed from one account to another within the same social network. For example, identity theft or falsification, increase or loss of reputation, account control for use in botnet type attack, among other new form of cyber attack adapt to this communication site. We only get one paper that related to this subject, and then the objective is cyber. They use algorithm deep regression model, and the accuracy only 0.86. Okay, we come to conclusion. There are various threats in social media networks such as identity theft, spreading false news like hoax, and then social engineering fraud message, and many other frauds. The goal of this research is to conduct a state-of-art literature review on the detection and prediction of various types of cyber attack using social media network. Our study concludes that the use of machine learning, deep learning, and natural language processing tool contribute to the better detection of many types of threat in social media posting message. There is a lacking research that focusing on detecting cyber attack on same social media network. Future research from this result from this review, there are two prospects for future research. First is the first prospect is to improve the accuracy value in predicting and vulnerability to exploit. And then the second prospect is research related to detection of cyber attack on the same social media network. However, in future research methodology, it is necessary to implement the most recent algorithm of machine learning, deep learning, and natural language processing tool to improve the effectiveness of the research. Thank you very much for your time. This is our presentation.
Okay, thanks for speaker. Are there any questions from the audience?
Thank you so much for
You
the
can.
presentation. I would
Okay.
request the chairperson if any of the questions for the author. Over to you, ma'am.
Okay, I have a question. There are many deep learning algorithms. So in the future work, which kind of deep learning algorithm would you like to apply in your problem?
Because this is our preliminary research, actually we don't really find the very good one. Maybe we will use like SPM. Maybe we combine or we make a comparison with random forest maybe. So we don't see that which one is better for our project. We just make
Okay.
comparison like that.
Okay. Okay. Let's thank the speaker again. And the next talk we will present by Vaidya K.A. And the paper title is Adaptive Multi-Attention for Image Sentence Generator Using CLSTM. Let's welcome the second speaker.
I think the participant has to stop sharing his screen. I'm not able to share.
Can you unshare your slides? Hello.
I would request you to please start sharing your screen.
Because the earlier speaker has to stop his sharing his screen.
Okay. No. Now you can share your screen.
It's not allowing me to share. So very good afternoon to all the audience and the panel members. So my topic of discussion today will be, that is my paper presentation is on adaptive multi-attention for image sentence generation using CLSTM, where C stands for CNN. So the earlier presented work includes CNN and the existing work, existing dense networks for pre-processing. So we kind of try to accomplish both text and video processing using CNN and LSTM. So my co-authors are Krishna Kumar and Cynthia. And this is a brief introduction of what is attention mechanism in image sentence generation. So attention is nothing but a mechanism in deep learning which actually has a certain weights to process the data. So given the input and also the text, how well the text matches with the input image. So that is the idea of the whole problem. So the existing literature, they've addressed how to use the image and take the image and do an adaptive attention using LSTM. So we kind of try to improve the existing work by adding one more LSTM layer for both visual and textual features. So we took both visual features and textual features and we combined both, and we try to find better optimal sentences for the given image. So this is the idea. So earlier on, there were a lot of works using visual sentinel and textual sentinel, but we kind of try to merge both CNN and LSTM to get an improved accuracy. So that is the idea. So the objective of the work is to generate the semantic concepts for the learning framework. So for a given image and the sentence, how well a particular sentence is matching. So that is the idea. So this is a literature survey. So the existing works mainly used it was proposed by Hoffman. So he used titles from captions and visual concepts also. So here he used a deep multimodal similarity model with the COCO dataset, whereas we used Flickr dataset and also COCO dataset. The comparison is done only with Flickr dataset. So here Andrej Karpathy is another author. He proposed a system for the same visual sentinel generation. So he used deep visual sentiment and alignments for image descriptions. He used CNN and LSTM. So we have modified this in a bit. We have used double LSTM in order to generate a much more semantic aware concepts with the ground truth that has been expressed with the Flickr data. So this is a problem statement of my work. So here, there are many factors for image description model, and the global features are easily achieved. It can be easily read by CNN without even giving any description about the input. And a long-term, short-term memory has been used because since for every frame we have to know what is the text that is involved, what is the image that is involved. So we thought the time-based recurrent neural networks can be an optimal solution for this. And also, this is the interior details of the DNN network that has been used. So we will have a certain refinement of the features that we are taking in LSTM model compared to RNN model. So here there will be three phases: the encoding phase, decoding phase, and an evaluation. We have used Blue Score for comparing the work that with the baseline system and with the the proposed system. So here, if the output score is always between 0 to 1, if the score is around 1, the system works well. However, the Blue Score, what we are able to achieve is around 64 to 65. So our future work, maybe we thought we will use BiLSTM such that the CNN network can be even more improvised. So this is a block diagram of the model where the image features are taken. We have used DenseNet for taking the image feature. We have used the pre-trained model and we have extracted the image features. Whereas for text processing, we have used scriptgram model and splitted the words into tokens. And then we have taken the vector for the words, that is the text that is present. So each and every image will have 5 sentences accompanied with it already existing. So we will take that sentences on whatever sentences we are able to identify. So we will form a vector fusion and then we will give it as an input to LSTM. And again, an adaptive attention using both visual and textual features are planned. And again, the output layer also, we are adding again a refinement for the features that has come using again another layer of LSTM such that the images actually, the output is improved. So this is a basic architecture of LSTM. So what is the difference between RNN network and LSTM is that, so we will have a refinement of features that is extracted, that is contextual features can be refined or filtered using LSTM better. Whereas in RNN, we will have a single gate which will take all the inputs on the, based on the time series that we are addressing. So this is the input. So we are getting an unlabeled image to the CNN model, and we are tokenizing all the text data also. So it is kind of a multi-label classification problem. Here, again, as I told, there will be encoding and decoding phase, and the output will be there. So this is the implementation that we have done in Python. And this is a tokenization model. So the predicted output will be the sentence that is generation. So we have modeled the dense layer, and we have used an embedding. We have given certain internal dense layers also, and the activation function we've used is, I think, yeah, we have used cross entropy, and loss function is cross entropy, and we have used an Adam optimizer function. So the accuracy we were able to achieve is 84%. So this graph shows this loss is decreasing even with the number of epochs, whereas accuracy improves with the number of epochs. So even if we increase, maybe we can try with many epochs also. It will give even more better results, but the maximum results we were trying to achieve was 84%. So we try to remodify this work using BiLSTM, maybe that could be our future work. So this is an input image, and this is a ground truth sentence that is that comes along with the data set, that is Flickr R data set, whereas the blue score we were able to achieve is 0.62, and this is some of the coding inputs, and this is the image caption. So this is the data set that is a standard data set with 8,000 images, and there are 5 sentences that is there, and blue score is a common blue score. There are other score functions also. However, we have tried with blue score, and this is a platform and tool that has been used, and this is a conclusion. So here we have used caption generation as a major work using both visual input and textual input, and we were able to achieve around 84% of accuracy. So test accuracy of 500, maybe for testing data set we have used 500 images apart from the training set whatever we have used. So as a future work, we are trying to use various DL methods and compare this image captioning or image sentence generation work with all the DL approaches like LSTM, BiLSTM. Maybe transformers will also even get a better results. That's what we thought. So the comparative and analysis of all this different DL algorithms is planned as a future work. That's it. These are the references, and thank you.
Okay, thanks to the speaker. Are there any questions from the audience?
There's no questions on the chat box.
Okay, and I ask one question. So, do you have any idea how to improve the accuracy, or I don't see. And another question is about the efficiency of this algorithm. I don't see you mentioned about the running time of this algorithm, because the running times should be important, because if you want to apply this algorithm or the program in a robot. So that's my 2 questions. Yeah.
Yeah, so running time, actually it took a lot of time because the images was very large, the data set is too high, so we had quite a lot of running time. So that's kind of so that's why I didn't mention it here. Maybe we in a future work we will try to reduce that running time also. So because for training itself it took a lot of time. So training is all the images along with the system. Maybe for the first initial pre-processing we had no problem because we used a pre-trained model like DenseNet. However, when coming to the original training part of the image, we're just combining all the features and giving it to CNN and LSTM, it had quite a lot of running time. So we are trying to address that. Maybe in future work, I'll try to, give a comparative analysis of the timing work also. Maybe the second question.
Okay, thank you.
Thank you.
Okay, let's welcome the third speaker, Pin Jong Xie. And the paper title is Adoption of Cloud-Based Communicable Disease Surveillance in Taiwan, Chief Information Officer's Perspective of Hospitals. Let's welcome the speaker. Okay.
Thank you, session chairs. I'm Beyond Shares. Okay, you can see that my slide. Okay.
Not yet. Okay, no, it's okay. I can see you. It's
Okay.
disappear again. Okay, now it's gone. I cannot see your slide. Can you share the screen again? Okay.
Right now,
Yeah, yeah.
can you see
And
my
you
slide?
need, yeah, yes, and you need to full screen.
Can I
full screen
start
your slide.
presentation?
Yes, yes.
Okay, thank you. Okay, thank you, session chairs. Hello everybody. My name is Beyond Shares, come from Taiwan. Today I presentations my papers. Then as adoption of the cloud-based communicable disease surveillance in Taiwan, CL perspectives of a hospital. To effectively collect, analyze, and monitor epidemic information among the hospital, the Taiwan CDC has applied the cloud computing application building the CCDS platforms by using the hospital information system and connecting the VPN to help the hospital reported inpatient cases. The Truth Cloud application and the aims of the CCDS are to increases the timeliness of the reports from notifiable disease surveillance system through the hospital EMIs to establish the laboratory automated report system that way. Sorry, it's monitor. We adopt the examination result from this in order to analyze and trace and the anomalies of the passengers. The CCDS allowing the infection controls to simplify many of those reporting procedure and improve patient safety more efficiently and cost effectively. It also enables the hospital to automatically receive a test result and reduce the need for the manual entries. Thus, to get the CCDS enables benefits, hospital must first adopt the CCDS. In a research purpose, provide a comprehensive set of the key factors driving the adoption of CCDS through the TOE framework, investigate the impact of the technological, organizational, environmental, transaction cost, and the social insurance context on CCDS adoption. In the literature review, the TOE framework posits that technology adoption depends on the technological, organizational, and the environmental context. The IDT states that fire innovation attributes such as relative advantage, compatibility, complexity, traceability, observability, influence organizational technology adoption decision following the journal guidance of the IT research. Relative advantage, compatibility, complexity are included in our research. The TOE framework perspective overlays the IDT's innovation characteristic. In the TOE framework include a cognition of the innovation characteristic from IDT, the IT internal and external organizational feature include the context as those in the TOE framework organizational context. So there are also main difference between the two theories. The IDT subjects including individuals' characteristic. Whether the TOE framework does not specify root of the individual characteristic, the IDT does not concern the influence of the environmental. Whether the TOE framework provides overall perspective for explain innovation adoption. So we combine the IDT, the TOE framework to understand hospital CCDS adoption decision. Here, TCT provides the framework of the 3 determinants that are leading to risk of opportunities, access, specificity, uncertainty, and frequency. The SEC states that the people and the organizational interact to maximize their reward and minimize their cost. The science researchers have proposed several determinants based on the concept that the IT adoption can bring the benefit, positing that the IT adoption depends on exercising power, reciprocal investment, reputation, and trust. So this studies mainly user relational factors to identify the factor, the determine intention to adopt CCDS. This model is our research models to explain the organizational decision related to the CCDS adoption. The models process that technological, organizational, environmental, transaction cost is change context influence CCDS adoption in a hypothesis. When hospitals have experience with the developing and building the health IT, they can use higher levels of technological readiness to support of the CCDS. The internet-based connection from the hospital to CDC can view as a potential security concern, which may diminish hospital readiness to adopt CCDS. If CCDS is perceived as offering more benefits, will compare with existing practice and systems, so IT adoptions will be encouraging. The CIO may perceive CCDS as compatible if fit well with the hospital's current environment. The adoption of a new IT is inhibited if the adopters perceive it as a complex. Conversely, the easier it is to incorporate CCDS with the organizational operations, the greater the opportunities of its adoption. Hospital ownership may guide organizational strategy based on hospital value and mission. Thus, hospital ownership can influence CCDS adoption. Hospital size can also influence the adoption of cloud computing because large hospital associated with the more financial capabilities. An organization internal needs can also serve as the project strategies by using CCDS. The time required to improve data can be significantly reduced, thereby promoting CCDS adoption. Adequate resources are critical to adoption success. If a given hospital have a sufficient adequate human resource support and empathy, then the CCDS adoption will be met positively. When top managers understand the importance of CCDS, they tend to play a critical influence in other staff members to use it. The CDC can offer the IT infrastructure of financial incentive, project promotion and consulting. Then hospital might choose to adopt CCDS and then reduce the time required for reporting. Pressure from the healthcare partners and the competitors may trigger the hospital adoption of the newer technology. By adopting CCDS, the hospital can gain advantage, greater work efficiency, and higher speed in conceiving test result. The access specificity in CCDS are human, physical, and temporal. Access specificity stressing the cooperative relationship between the hospital and the CDC. Uncertainty increases the need for appropriate ways to negotiate the contracts between the hospital and the CDC, as well as the requirement for greater flexibility in coordination. Regarding the unforeseen problems, the high frequencies will facilitate higher incentives for hospital increases their coordination. The CDC taking the CCD projects often exercises its powers to immediately influence hospital actions, for example, by offering a reward and assistance, reciprocal investment implies that business partners intend to guarantee a stable cooperation, operative relationships, such as reciprocal investment between the hospital and the CDC in a training workshop and facilitation sharing. Trust facilitates information exchange and improve the effectiveness of joint problem solving. The data collection, the target participants were the CIO from the Taiwanese hospitals that had not adopted CSDS, the resulting 206 valid response accountability as response rate of 85.48%. The majority of the questionnaire respondents were male between the age of 41 and 50 years. The statistic testing partial support research model, the result indicated relative advantage, hospital science, top management support, governmental policy, competitive pressures, uncertainty, and trust have a significantly affected CSDS adoption. In a discussion, this study provides several implications and contributions. This is different from pilot studies on the cloud technologies, which for sure of assessing the integrated influence of the economic and social factors. So we offer a new perspective for the future researchers that may help in encouraging the hospital adopt cloud technologies. Next, our studies can confirm that uncertainty is a critical economic factor inhibiting technology adoption concerning the role of the social factors, the driving forces positively affect CSDS adoption. These studies also have several implications for parties. The Taiwan CDC show focus more on promoting CSDS benefit when marketing its healthcare service to hospital for CSDS adoption. When hospital managers are familiar with the relative advantage of CSDS, this eliminates their uncertainty about CSDS use and enhances their willingness to adopt the system. Thus, the government working closely with the hospital must develop long-term implementation plan, intervention strategy, and workshop to drive CSDS adoption. The CDC could offer a training program to help smaller hospitals in upgrading relative technological capabilities, which would in turn increase their willingness to adopt CSDS. System managers' preparations for the training and consulting the service for hospital IT staff can increase technological barriers and uncertainty at the initial adoption stage. Finally, the Taiwan CDC could take a stronger position about providing financial aid and IT trainings for the non-adopters, and it should build related policy to promote CSD to hospital. Thank you for your listening. Thank you.
Okay, thank you for the speakers. Are there any questions from the audience? Okay.
None of
And
the questions
ask,
in the chat box.
no? Okay. I ask one question. So just curious. So how much time did you spend to collect all the 206 valid response from the hospital?
We use about half years.
Half year, not
Yeah.
not long. Okay. And the second question is, do you have any idea to extend the result obtained from this paper in the future work?
Future works.
Yeah.
This paper is my project about the project. We extend these plans about the infection control staff for individuals adopt CSDS perspective.
Mm-hmm. Okay.
So we use about, for example, UTA, UT, and TTF models. TTF model is a task technology fit model. Yes.
Okay.
So this is my future work.
Okay. Okay. Thanks, the speaker. And let's welcome our fourth paper presented by Queen Dong Luo. And the paper title is Analysis of Development of Electrification of Urban Public Transport in China based on Life Cycle Cost Theory. Let's welcome the speaker. Okay, you can start now. We already see your slides. Hello? We can't hear you.
I would request you to please unmute yourself and start with the presentation.
Can you hear my voice?
Yeah,
Yes.
you are audible.
Yes.
And there's a screen?
Yes.
Okay.
Hello? I can't hear any voice now.
I would request the speaker to please increase volume settings from the computer. I would request that we are not audible for your presentation yet. The audio of the presentation is still not audible. I would request you to please check the settings. As due to some technical issue, we are not able to hear the presenter's voice. And I would request the chairperson, we shall be beginning with the next presentation. And we have the next presenter. I would request to sir to please stop the sharing the screen and please solve the technical problem. Moving to the next paper title, we have analysis of an effective ZONO GED solar cell using SCAPS 1D. I would request the author to please start sharing your screen, and I welcome Mustafa Amsala to represent this paper. Sir, over to you.
So let's wait Lord Kundono to solve the technical problem now, and if you cannot solve the problem before during your presentation slot, and we can ask the committee member, maybe they can put your video in some web page. Okay.
Due to the technical issue, the presenter was not able to with the audio. So moving to the next paper title, we have the looping through color space, a simple argumentation method to improve biased object detection. And to present this paper, I would like to welcome Pascal Lambert. Over to you, sir. I would request you to please start sharing your screen and start the presentation.
Okay, thank you very much. So, can you see my screen?
Yes.
Perfect. So, hello everyone and welcome to my lecture. My name is Pascal Lambert and I am one of 4 authors of the paper titled Looping Through Color Space, a simple augmentation method to improve biased object detection. I would like to give you a brief overview of what to expect in the next about 50 minutes. I would like to start with the motivation and the problem we were confronted with, followed by the approach we have developed to solve the problem described. After that, we show some results of the evaluation and finally a short conclusion. In this work, we address the challenging problem of color-dependent and imbalanced datasets. For many use cases, the training of models based on such data will not generalize well enough and fail even on slight domain variations, like in this simple example of a hand detector that recognizes hands without any problem, only failing miserably with worn gloves, whose color is clearly different from the color of the skin. The underlying variation is obvious and can be circumvented by making the color variation no longer part of the training data. This means that the model no longer has the possibility to recognize and learn the color variation as a pattern. So instead of the RGB images, the depth images were used, which cannot capture the different skin and especially glove colors. And therefore, changing the domain in terms of color variation is no longer a challenge for the model. And it can detect every hand in every picture or image. So what does the model actually see? Here we have 3 images, the first in RGB, the second in grayscale, and
我那个不是
third...
在搞那个会议的视频嘛，结果我那个分享屏幕好像不行的哇。
Could you please mute your microphone?
就是 Zoom 呀，然后就是它不是有个共享屏幕嘛，然后我点。
Thank you. So I will start again with the slide. So what does the model actually see? Here we have 3 images, the first in RGB, the second in grayscale, and the third as HSV colorization. Even though we are in the depth range, we still have color variations that arise because the objects are at different depths from the camera. By the way, it should be mentioned that we achieve better results with the HSV color map than a simple grayscale coding when we train a model. But that is not the only reason for using the HSV color map. More on that later. I want to give a more detailed insight into encoding the depth with the color giving coding. Shown here is the reference function of the HSV color map. The color levels corresponding to the depth values are plotted on the x-axis, and each depth value is mapped to 3 color values, red, green, and blue, which in combination give the color of the pixel. But what exactly does that mean for our data? The histogram shows the relative frequency of the objects depending on the color variation. As a reminder, the colors represent a certain depth of the objects to the camera. This means that a large part of the data contains, in this case, hands, in a depth range of about 800 to 1300, predominantly in the blue color spectrum. So the collected data set covers only a particular depth range for the appearance of objects, which is leading to an undesired depth sensitivity. As a result, the model trained with such data might not generalize well to detect the same objects in other depth ranges, for example, in the yellow area. Furthermore, the problem is not solved by mapping the depth to other color maps because the imbalance is just shifted from depth to color space. To reduce imbalances in datasets, we introduce a method to extend the data by rotating the color map artificially. The annular arrangement of the HSV color map is displayed here with angle indications and marked boundary point here at the arrow. The course of the pixel values of the reference function is chosen so that the last color, pure red, also represents the first color of the color map. This means that the HSV color map is a periodic or cyclic color map and has a soft overflowing boundary point. In principle, all color maps can be rotated, but the choice is crucial as some will create undesired side effects, such as artifacts in the image. Such artifacts are mainly edges in the middle of objects due to visible transitions at color map borders, for example, grayscale or viridis color map, like the one shown here on the right. The viridis color map reveals a jump from purple to yellow at 0 degrees here. The augmentation is performed by random rotations of the HSV color map so that the encoding of the depth values is performed with different color levels in each case. The same rotation must be applied for each pixel to convert an entire image, but it's possible to rotate the color map several times for the same raw depth image. Here you can see random rotations of the color map resulting in 5 augmented images from a single depth image. The result is a high variation in the color appearance of the hands. When looking at the left hand of the worker, which is blue in the first image, there is a red coloration in the second and third images due to the small differences in the angles. In the first image of the second row, there we have got a green hand, and in the last one, it's light blue. Let's take another look at the histogram of the relative color frequencies of the collected dataset. For a static HSV color map, there are strong disbalances in the data, which lead to an undesired side effect, undesired depth sensitivity, sorry. If the proposed augmentation method is now used, depth information is distributed over the entire encoding range of the color map by rotating it randomly, and thus eliminating existing imbalances. Due to the augmentation method, a more uniform distribution is achieved. To evaluate our approach, we trained hand detectors with the augmented data. The model V trained on the biased dataset serves as baseline. In addition to a full rotation, M-AUG full, of the color map, a partial rotation was also tested, where only angles of 70 degrees clock and counterclockwise were performed. The result is a clear improvement in the performance of the models with augmented data, whereas there are no significant differences between full and partial rotation. To evaluate the trained models MHSV, M-AUG full, and M-AUG partial with respect to color independence, two different evaluation datasets are introduced. Therefore, the first evaluation dataset is encoded using HSV color map, and to determine a model's color independence, we artificially extend second set by color map rotation to cover the whole color map range. The model performance in both evaluations, naming F1 HSV and F1 extended, must show comparable results to achieve color independence. On the other hand, if there are significant differences in the evaluation metrics, there is likely an expression of color sensitivity. When comparing the differences of F1 HSV and F1 Ext for each model, the MHSV recorded the most significant performance spread with -50.3% for the two evaluation sets. Thus, the model seems to react sensitively to color mapped depth ranges, which are predominantly present in the training dataset. The model M-AUG partial shows similar but less distinctive behavior. The constrained rotation resulted in a better detection performance of F1 extended, but the M-AUG full shows no significant differences in F1 scores, and therefore a color independent detection can be assumed. In the following, the frequencies of detections and annotations are compared with respect to the different color levels. The annotations are displayed in a lighter gray in a histogram as a discrete distribution in the different color levels corresponding to the depth values. Subsequently, the indicated model's true positive detections were plotted against the annotations in darker gray. The conformity of these two distributions can be interpreted as recall, and the aim is to achieve the maximum overlap and therefore a recall of almost 100%. Only moderate differences can be seen in a direct comparison of the histograms of the models when evaluating them with an evaluation set, including the further mentioned disbalances. When using a more uniformly distributed evaluation set, which has no disbalances included, the distributions visualize color-sensitive models MHSV and M-AUG partial, because true positives are not approximately equally present in all color levels. In contrast, the detections of the M-AUG full model are evenly distributed over the entire evaluation set, and no color level preferences are apparent. Additionally, for model M-AUG full, with better balanced input data, the true positive rate per color level is significantly increasing for the dominating colors of model MHSV, between 800 and 1300. As a result, the assumption of color independence from the previously shown table is confirmed. In summary, it can be said that datasets with high disbalances are a challenging problem and are leading to an undesired sensitivity with respect to the object's appearance and bad generalization of the trained models. Therefore, we proposed an augmentation method called color map rotation, which eliminates the imbalances, reduces the color independency in the depth domain, and increases the data volume. So thank you for your time, and I'm now available for questions. Thank you.
Okay, thanks to the speaker. Are there any questions from the audience?
And now for questions in the chat box, I would request you to please proceed with the question if you have any for the author.
Okay, I have one question. Yeah, are there, do you have any idea for the future work or find the application of your result?
One application would be that when you have data sets with high disbalances and are not able to acquire new data to get rid of these disbalances, this method could be one approach to overcome this problem. So you don't have to gather new data.
Okay, okay, thank you. Thank you. Okay, let's welcome the next speaker.
So the next paper we have for the speaker is Mustafa M. Salah, and the paper title is Analysis of an Efficient ZNO divided by GETE Solar Cell Using SCAPS 1D. I would request the author to please start sharing your screen and start the presentation. Over to you, sir.
Thank you. Hello, everyone. Nice to meet you all. I am Mustafa Muhammad Salah, Assistant Lecturer at Future University in Egypt. I will present the paper titled Analysis of an Efficient Zinc Oxide Germanium Telluride Solar Cell Using One-Dimension Solar Cell Capacitance Simulator. The rest of the authors of this paper are Dr. Abdel Halim Zikri, Professor at Ain Shams University, Dr. Muhammad Abul Ata, Professor at Ain Shams University, Dr. Ahmed Shakir, Professor at Ain Shams University, Dr. Ahmed Saeed, Lecturer at Future University in Egypt, Dr. Muhammad Musa, Assistant Lecturer at Future University in Egypt. The outlines of this presentation: firstly, the introduction; secondly, germanium telluride zinc oxide solar cell proposal, then optimizing the proposed solar cell, thickness optimization, and doping optimization. After that, a comparison of the initial and optimized cell designs will be presented. Finally, the conclusion and the future work. Nowadays, the energy demand is rapidly increasing. Clean energy, especially from solar cells, shows a promising solution for this problem. The move from the conventional to green energy is related to a set of principles. One of these principles is to increase device efficiency and reliability. Currently, the photovoltaic market is dominated by silicon solar cells and relatively new materials like perovskites and copper, indium, gallium, selenide. Although these materials show a good performance, they have limitations of performance and also costly or unstable. Consequently, the strategy for improving the performance of single junction solar cells in this paper is based on the use of new promising material. The promising material is germanium telluride as an absorber layer. Germanium telluride has high electrical conductivity and a small energy gap, which allowing it to absorb a larger portion of the input spectrum. The structure of the proposed solar cell is consisting of a glass substrate, fluorine doped tin oxide as a transparent conducting oxide, zinc oxide as N material, germanium telluride as P material, and gold as back contact. For the interface between germanium telluride and back contact metal, a flat band model is utilized. For all analysis, the incident spectrum is air mass 1.5 at room temperature 300 Kelvin. The energy gap for all materials are shown in this figure. The simulation parameters of germanium telluride and zinc oxide materials are listed in this table. The energy gap in electron volt of germanium telluride is 0.8 and of the zinc oxide is 3.3. The thickness in nanometer is 500 for the germanium telluride and 300 for the zinc oxide. The relative permittivity is 36 and 9. The electron affinity Xi in electron volt is 4.8 and 4.6. The effective conduction band density per centimeter cubed is 10 power 16 for germanium telluride and 2.2 times 10 power 18 for zinc oxide. The electron mobility for both materials are 100 per centimeter square volt second. The donor density per centimeter cubed is 10 power 18 for the zinc oxide. The effective valence band density NV per centimeter cubed is 10 power 17 for germanium telluride and 1.8 times 10 power 19 for zinc oxide. The hole mobility is 20 for germanium telluride and 25 for zinc oxide per centimeter square volt second. And the acceptors concentration in the germanium telluride layer is 2 times 10 power 16. The defect density is 10 power 14 for germanium telluride and 10 power 15 for zinc oxide. The JV curve of the proposed solar cell shows the open circuit voltage of this cell is 0.55 volt and high short circuit current density of exceeds 5 milliampere per centimeter square and a fill factor of 78.48 and a power conversion efficiency of 21.58. The quantum efficiency is shown in this figure. The cutoff wavelength of the quantum efficiency is 1550 due to the energy gap of the absorber material, the germanium telluride. The solar cell, this solar cell shows stable performance metrics with temperature variations. The thickness of the solar cell layers can be modified to improve the performance metrics. Furthermore, the conductivity of used material in solar cells impacts the performance parameters. The doping could be N-type or P-type can be used to regulate the conductivity of these materials. Firstly, thickness optimization. The effects of germanium telluride and zinc oxide thickness have been studied. The influence of germanium telluride thickness on performance metrics is shown in this figure. It can be shown that as the thickness of the germanium telluride increase, the performance metrics increase. But no significant changes after 3.5 micrometer. So we will choose this value for the thickness of this layer. The performance metrics, in this case, the power conversion efficiency is 26.99 and fill factor 82.37, open circuit voltage 0.62, and the short circuit current density 53.21 milliampere per centimeter square. At this, it can be shown in this figure, the thickness of zinc oxide decreases the performance metrics. When it increases, the performance metrics decrease. So we will choose 10 nanometer for the optimum thickness of zinc oxide. It can be shown as the thickness of zinc oxide decreases, the performance matrix enhances, but no significant change below 10 nanometer. At this thickness, the cell has a power conversion efficiency of 27.16, fill factor 82.37, open circuit voltage 0.62 volt, and current density 53.53 milliampere per centimeter square. The doping optimization. The effect of germanium telluride and zinc oxide concentrations, doping concentrations, has been studied. This figure shows how the concentration of germanium telluride doping affects the performance measures. As the doping of germanium telluride increases, the performance increases. The performance metrics are enhanced till 3 times 10 power 18 per centimeter cube. Then the performance metrics decrease. At this doping range, the power conversion efficiency is 29.11 and the fill factor is 74.83 and the open circuit voltage 0.75 and the short circuit current density 52.1 milliampere per centimeter square. This figure shows the doping effect of zinc oxide layer. It can be shown that the doping concentration of zinc oxide increases the performance. But no significant enhancing after 6 times 10 power 90. And the power conversion efficiency at 6 times 10 power 19 per centimeter cube are 33.18, 84.95, 0.75, 52.31. A comparison of the initial and optimized cell designs. The JV curves of the initial designed germanium telluride cell and the optimized thickness and doping concentration are shown in this figure. The power conversion efficiency increased from 21.58 to 33.18. The fill factor increases from 78.48 to 84.95. The open circuit voltage increases from 0.55 volt to 0.75 volt. The short circuit current density increases from 50 to 52.31 milliampere per centimeter square. For more physical explanation, these figures show the energy band diagrams of the initial and optimized cells. As shown in this figure, the spike in this conduction band, the offset of the initial design, is solved after optimization. The conclusion, germanium telluride is a promising material due to its high open circuit voltage and short circuit current density. Besides of its high electrical conductivity, its low energy gap contributing to germanium telluride's high short circuit current density, which allow it to absorb more of the incident spectrum. The power conversion efficiency increases from 21.58 to 26.99 when the absorber layer thickness is increased from 0.5 micrometer to 3.5 micrometer. Decreasing the thickness of the zinc oxide layer to 10 nanometer increased the power conversion efficiency to 27.16. Optimizing the doping of germanium telluride and zinc oxide layers after optimizing the thickness increases the power conversion efficiency to 33.18%. The simulated design should be applied practically to verify the output performance parameters, which will be considered in the future work. Although this cell could be used as a part of a tandem solar cell as a bottom cell. Thank you.
Okay, Thanks, the speaker. Are there any questions from the audience? No. Okay, let's thank the speaker again. So, are there any other?
That's the end of the speakers.
Okay. Okay. That's the end of the speak, and let's thank all the speakers in this section. And do you have any further information to announce?
I sincerely thank our authors for their excellent presentation and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. All the presenters would be getting their digital certificate through an email within 2 working days. Further, all the papers have already been forwarded to the Springer. The publications will be live within 5 to 6 months. Kindly cooperate with the team of ICICT 2022. I also thank our session chair for chairing this session. A token of appreciation to the chair on behalf of the team of ICICT 2022 and Global Knowledge Research Foundation.
Okay. Okay, thank you.
I would request.
Thank you.
You're welcome, ma'am. Thank you for your valuable time. I would request all the presenters to kindly switch on your camera for a memorable snapshot of the presentations.
Okay, so all the participants of this section, please turn on your camera, and we take a photo together.
Thank you so much. Stay safe, stay healthy. That was a great presentation. Thank you for your valuable time. We would be leaving the meeting soon, and I would stay safe. Thank you.
Okay, so bye-bye. Bye-bye.
Have a great day.